It's a good shirt, though, right? It's a good shirt.
I understand
It is. It's a great shirt.
Like,
Have you not seen Talladega Nights?
what it is.
Talladega Nights.
You've never seen Talladega.
All right, so he'll watch that. Carson, you'll introduce him to that. We're going to talk about the ambiguous case. So, of the 4 days, law of signs, pretty simple. Yesterday, area, even easier. Today, ambiguous case, might be a little ambiguous. It might be a little bit nebulous for some of you, but hang with me because it's really not that bad. And then on Monday, law of cosines is not a big deal. So, of the 4 days before your quiz, today's the one that I think you should pay the most attention to. So, you're given some information today. If A is acute, like this one is, and if they give you sort of this adjacent side next to it, and we're going to call that B, because over here, B is somewhere. We're not sure where. And they tell you how long the third side is. Let's say the third side is, and I'm going to drill this in. That's the height, right? That's the height, yes?
Yes.
Do you remember from yesterday when I was deriving that formula for you, we found out that H equals B sine of A. Do you remember that? If you don't remember it today because you have to know it. The height is the same thing as if you did B sine A. Or this side, whatever, sometimes they call it C, sometimes it's D, sometimes it's W. Whatever this side is here, this side times sine of this angle that's with it. That's how you get the height. And let's see, I think it's this little guy right here. How many distinct or unique triangles can you make with if A is that long? Exactly one, right? I can't do anything else with it. It's straight up and down. It is what it is. But what if they tell me that side A is only this long? Well, it's shorter than the height. How many triangles can I make with that? None. It doesn't ever reach this side, right? It's not going to. So you're going to have some problems today where you're going to say, not possible, or can't make any triangles, sorry. Or what if the third side was shorter than 32, but longer than the height? Now think about this. How many triangles do you see now? Whoops. One, right? One. Or, watch what happens. What if I swing this guy out this way? It makes two. I didn't change the orange paper. I didn't change the angle. I didn't change that side. This length, if A is between this length and this length, there's two triangles that are possible. And you're not going to know which one it is unless they tell you. Which means you're going to have to list both of them. Does that make sense? A little bit. If the third side, if the orange side is between these two lengths, then it makes two triangles. That's what you got to know. What if I had an orange piece of paper here, and I forgot to cut one, that is longer than 32? How many unique triangles will that make? One, right? If it's longer than 32, I can't swing it in and make a triangle. The only way I can go is out, right? So that would make one. Y'all with me? Yes?
Yes.
All right. We pass out a piece of paper. You're going to get this page right here. You don't have to write any of that. Oops.
So,
Uh-oh, who's first? What'd you say? Okay, so pass those down. Not a little. So let's take a look at this. This is the summary of the ambiguous case. Ambiguous meaning, we're not really sure what triangle we're looking for. If angle A is acute, so that's the first thing you have to look for. And they're not always going to call it A, by the way. Sometimes it's B, sometimes it's C. It might be a different letter. But whatever angle they give you, I always kind of tuck in this bottom left-hand corner. We're going to call that A. If that's acute, and A is smaller than B, side A, this third side, if it's less than this one, that's the one we just talked about. There are three options. You could have two solutions, one solution, or no solutions. And remember, this B sine A, that means height. So they kind of have the drawings all kind of done for you. Number 2, if A is acute and A is greater than B, that's the one I just said I forgot to cut, then there's exactly one solution. You can't swing side A this direction and make a triangle. You've only got one option there. But here's what happens if A is obtuse, or if it's a right triangle. There are two possibilities. There might be no solution, or there might be one solution. If they give you this angle and it's obtuse, and you've got this side, and they tell you A is shorter, well, this is never going to reach all the way down there, no matter where you swing it. So there's no solution for that. We'd have one solution, of course, if this third side was longer than B. And that's only when A is obtuse. So bear with me. Hang on to this and use it as a reference sheet. Here are some examples we're going to do together. Oops. Here we go. Okay, and you guys, we talked about this, that height needs to be B sine A. You know that. All right, here's the example. It says to solve the triangle, and here's what they give you. A is 20, C is 16, and angle A is 30. And then they also ask you how many distinct triangles can you draw with those measurements. It's not asking you to draw it, it just says how many could you draw. And it wants you to solve the triangle. So let's see here. Angle A is 30 degrees. That's acute, yes. I don't know how far this line goes. Side A, that's the mystery one, is 20. The one that they give us is 16. And notice this time they're calling it C. Don't let that freak you out. It just means angle C is down here somewhere, which means this one's B. The third side is 16. What I need to know, guys, is that height right there. I need to know the height of the triangle so I can determine how many triangles I'm going to have to solve for. So height equals, normally we say B sine A. Is this called side B? It's C this time. So height equals 16 times sine of 30 degrees. Sine of 30 is a half. Half of 16 is 8. So the height is 8. They tell us that side A is 20. Well, 20, first of all, is longer than 16. So how many triangles can we make with it? Just the one. It's going to be all the way out here somewhere. So for that one, did you necessarily have to know what the height was? No, but I kind of want you to get in the habit of doing that. So we're only going to have one triangle, and then let's solve for it. You're going to use just law of sines. And by the way, I'm going to move this C so it's out here. So I've got A over sine of A, so 20 over sine of 30 degrees equals, we could do B over sine of B, or what makes more sense, C over sine of C? Yeah, because they give us 16. So 16 over sine of C. Everybody solve for C. We get 23.6 degrees, I believe, for angle C. I also need angle B in order to solve this triangle. So we take 180 minus 30 minus 23.6. Which you guys get 126.4? Degrees? By the way, on that last test, I didn't take off if you didn't put a degree bubble. I should have. The slaughter would have been worse, but I didn't. I thought, all right, I'll give you something. Yes, you're welcome. Thanks for being grateful. All right, so we have C and B. So now I just need side B. So B over sine of B equals A over sine of A. Did you guys get 32.2? And reasonably, when I look at the triangle, that makes sense. I knew it would be longer than 16 and 20, so that makes sense. Questions on how you're going to solve when there's one unique triangle? Everybody okay? Next little guy. Triangle ABC has some givens here, and the only question it says is how many distinct triangles can you draw? It doesn't say to draw them, it just says how many can you? Like how many are possible. Let's think about this. Angle A is acute again. So I'm going to tuck it back down in this corner. And it says that side C, so they're calling this C again, is 16. Well, this is looking just like the last problem. And we already calculated the height was supposed to be 8. They say this time that side A is 7. What does that mean? Well, if the height is 8, 7 is only going to get you that far. Is it ever going to touch that third side? Nope. So how many triangles can you make? None. Eventually you get to where you don't need to draw a picture, but I like the pictures. Visuals are good. Everybody okay on that? Need more time? Okay, next page. This is sort of our last example together. In triangles ABC, A is 10, B is 16, A is 30 degrees. Again, how many triangles can we make? So let's see here. Here's my line. Here's my 30 degrees. And they tell us this time they're using B, and it's 16. So B is over here somewhere. I don't know where. And here's my C. Again, we've already figured out the height. We determined that that was 8. They're telling us that A is 10. What does that mean for us? There's two triangles. It's between these two lengths. If it's shorter than this guy, but longer than this guy, you've got two options. That triangle might go here, or it might go here. All right, so we have two triangles. Here's the deal, is you don't really know how to solve for two triangles yet, so let me teach you. You've got two triangles, and I'll just tell you, on your quiz, you're going to have several that look like this, where they give you some givens, and then you've got to, like, solve the triangle. The answers will look like this. It'll go angle A, angle B, angle C, side A, side B, side C, and then there'll be more blanks. Angle A, angle B, angle C, A, B, C. And maybe you'll fill all of them in because you're solving for two triangles. Or maybe you won't fill any in and you'll say, not possible. So you're going to have to know. Yes, sir?
So how did you determine the two triangles?
Great question. Okay, do you remember, Logan, how I figured out that that was 8? B sine A, right? So B times sine times A gave me 8, which is the height. Because 10, side A, should be there and there, because it's shorter than 16, but longer than 8, I know that it's either going to go here or here, and I don't know which one because they didn't tell me. So it's two possible triangles. Does that make sense? Kind of? It's a lot to wrap your brain around. I get it. Okay, so here's the thing. We need to calculate this angle, and we're going to have to calculate this angle. So here's what we're going to do. B could be here, or it could be over here. Let's try this little guy first. We're going to calculate, let's see here. Let's do law of sines. A over sine of A, so 10 over sine of 30 degrees equals B over sine of B, 16 over sine of B. Let's solve for B. That's 4/5. I think it's 53. Is that what you guys got?
But, on that one thing, since the side is 10, what if it equals 16? Is it no solution?
If it equals 16, no, it could be an equilateral. It could be an isosceles triangle. You know what I'm saying? Hey.
Is Diana here?
No, I forgot to turn off.
Okay,
Sorry.
is Tanner-
Oh, wait. Where were you when I took attendance? You were not sitting there. Oh, man. No. Tanner is here. Diana's not. I'm sorry. I screwed that up.
That's all good, thank you.
Okay. I don't even remember that. Sorry, Tanner. I totally forgot. All right. I think my favorite pen just ran out. Sad day. Okay, so 53 degrees. Does this right here look like 53 degrees to you? That's an obtuse angle. No, so we probably just found this one. And I need to, I don't know, I'm going to point to it, I guess. That one right there is 53.1 degrees. Now let me show you something. You don't have to draw this. I just need you to watch. If this green line is 10 and this green line is 10, those sides are congruent, yes? And you know from geometry that if those two sides are congruent, then these two angles are congruent, yes? So if that's the case, then this one's also 53. How do I get this guy right here? 180 minus 53.1. Those are supplementary. That would be something that would be worth you writing down in your notes. That both options for angle B will be supplementary every time. So the other angle B we might have, 10. Correct. Carson's got it. So it would be 126.9-ish. So it could be two things. So again, in your notes, it would be worth writing down that both, both options, both possible angles will be supplementary every time. And now it's just a matter of finishing it out. So I'm going to start with sort of the first triangle we started where B was 53.1. Now I need angle C. How do I get it? You know this. Hello? I have two angles. Yeah, 180 minus 30 minus 53.1. There you go. And it's 96.9 degrees. We could do the same process on this one over here, actually. So 180 minus 30 minus 126.9. And for this triangle, C would be only 23.1 degrees. The only missing part we have now is we need to know what side C is, since we have everything else. So C over sine of C equals A over sine of A. I'm sorry, yes. That's how you find them both. For this guy, I got 19.9. Did you guys? Yes. Yes. You're going to have two answers. One for the first triangle and then one for the second triangle. Does that make sense? I think I got 7.8 for the other one. So now you have your first triangle and your second triangle. So you've got two options there. We don't know which one it is because they didn't give us anything to go on. Okay? So you're going to use that sheet I passed out. Check to see if the given angle is obtuse or acute. That'll help you. And if it's acute, you're going to have to calculate the height. B times sine of A, B times sine of A, B times sine of A. Calculate the height, and then from there you should be able to narrow down if it's no triangles, one triangle, or two triangles. Alrighty? Here's your assignment. Yes, sir. Yeah, if it asks you, then you just say two triangles. Yeah. Yeah, this one didn't say to solve it, but I wanted you to know how, so thought that was kind of important. Page 317, 2 to 36 even.